used. So there are dimensions, actually. Let me write them like this. So we have the length, okay? We have the length, then we have the mass. These are the three physical quantities that we normally look at. These are the ones that we use to derive other quantities. So we have the length, the mass, and we also have the time. So the dimensions for length, we know that it's capital letter L, and then you put the square brackets. The dimensions for mass is simply just capital letter M, put the square brackets. And then the dimensions for time is simply just capital letter T, and then you put the square brackets. So now, this is what you have. These are the basic things that we use. Now, let's say, for instance, we want to derive the dimensions for acceleration. Okay, let me start with the simplest, which is maybe velocity. So we know to say the velocity of any object or the speed of anything is given by the displacement. It's given by the displacement over what? Over time. So the change in displacement over time gives us what? It gives us the, let me use X to represent the distance. I mean the displacement. So the change in the displacement over the time is what we get, and that is what we call the velocity. Yeah, so we know that the displacement here is simply just the change in the distance, in length, let me say. So the units, rather the dimensions for delta x there are simply just the length. I mean, simply just this part here, because the change in x is simply just the length. So the dimensions for that is simply just L. So we put L there, and then over, then the dimensions for time is what? The dimensions for time is simply just capital letter T. So this is what we have. So now this can also be written as, we know to say, when I say 1 over 2, this can also be written as 2 to the power negative 1. So same applies to this. We know that we have L there multiplying with what? 1 over T. Let me do this, 1 over T. So this can also be written as L times T to the power, T to the power negative 1. So this is what you are supposed to write if they ask you to derive the dimensions for velocity. What of acceleration? So we have managed to find the ones for velocity, but what of acceleration? So acceleration, we know to say acceleration is simply just the change in what? The velocity over time. So what are the dimensions for velocity? So the dimensions for velocity are simply these here, what we have found there. So we have L, and then we have T to the power negative 1. So these are the dimensions for what? For velocity. Then we're dividing everything by T. So we're going to have the dimensions for time there. So this can also be written as L, then we have T, then we have this T. When we take it on top, like if you check this situation we had there, it became T to the power negative 1. So I can write another T to the power negative 1 this side. Yeah, so whenever you are multiplying two numbers with the same base, or two indices with the same base, what do? You add the powers. So let us add the powers there. So we have L, and then we have T there. So we add the powers negative 1 and negative 1 there. When we add, we get negative 2. So these are the dimensions of acceleration. So now, this is how you derive the dimensions in dimension analysis. Now, the question is, how can you know how to do this in a simpler version? So the simplest way to know how to do this, or how to derive these formulas, is just by using, these dimensions, just by using their units. So we know to say the velocity is measured in meters per second. So meters per second is simply just the m there over time. So the m there, so we have m over what? Over s. So what is the dimensions for m? So this is the meters. So meters is simply just the length. So the dimensions for the length is simply just capital letter L, and then over the dimensions for time. So this second, the seconds measures what? Time. So the dimensions for time is what? Capital letter T. So we can write it like that, and we simply just say L, then T to the power -1. So this is the simplest way of knowing the formulas for these expressions. Now, what happens if you have something like a force? We have something like a force. Okay, before we go to force, let us also write the dimensions for acceleration using its units. So its units, the units for acceleration are simply just meters per what? Per second squared. So we are going to have this meters measures what? The length. So we have the length on top there, and then down there we have time to the power t, to the power 2 rather. So we have t to the power 2. And then from there, if you have such an expression there, you can now write it in this format. And then you have, this means that you're going to have L, and then t to the power -2. So you have t to the power -2 there as one of the dimensions for acceleration. So these are the dimensions for what? For acceleration there. So these are the dimensions for acceleration. So it's as simple as that. So now let us try to find the dimensions for force. So we know to say force is equal to what? Mass times acceleration. So what are the dimensions for mass? Mass is capital letter what? M. Dimensions for acceleration, we have found them there. But if you want, you can use its what? Its units. So the units for acceleration are simply just m, which is the meters. Meters measures what? The length. So we put the length there, and then per second squared. Per second squared means t to the power what? -2. So we have t to the power -2. So I've just written what is here. So if this is what you have as the dimension for, yeah, so this is actually the dimensions for what? For force. So now, how do you use this, or how do you find the dimensions for force using its units? How do you find that? So it's very simple. We know that say force is measured in what? In newtons, and 1 Newton is simply just equal to kg meters per second squared. So now force is therefore going to be equal to, so we know that this can be written as kg times the mass, everything over the time squared, the second squared. So the dimensions for force will therefore be, so kg measures what? The mass there. So it's the mass, and then meters measures the length. So we put the length there. So when I'm dealing with dimension analysis, the only important part, I think, according to my understanding of this topic, is knowing the units. If you know the units of any quantity, it's very easy for you to derive the dimensions. Or if you don't know the units, at least you know the formula. If you know the formula, at least between the two, you should at least know something between the units and the formula. Then t to the power 2, this seconds to the power 2, seconds measures what? Time. So time to the power 2. So there's a 2 there. So this can further be written as m, and then we have L, then t to the power -2. All right, so this is how simple these things are. Okay, so now let us quickly look at a few questions. which I believe are simple questions. Okay. So we have this question here. So this question is asking us to find the speed of, rather, the question is if the speed of the speed of pressure, if the speed of pressure of a pressure wave is traveling, I think that was an error here. So we say if the speed of a pressure wave traveling through a fluid is affected by its compressibility, and then density, kinematic, viscosity. Use the dimensional analysis to find an expression for V. So in other words, what they're trying to ask us here is to find the formula for the speed of a pressure wave traveling through a fluid. So how do you know? So this is how important dimension analysis is. This is the importance of us learning this topic, because to help you to even know the formula without you necessarily knowing the formula, to help you to derive the formula without you necessarily knowing the formula. And this has helped me a lot, I think from my first year up until now. Yeah, so it has helped me a lot. There are times when I would go into an exam room without knowing, me meeting a question there, which I do not know the formula, but at least from nowhere, using dimension analysis, I managed to come up with the formulas. And then those formulas, you just discover to say, even after the marker marks, even after the lecture marks, I'll get the question correct. It's not that maybe I mastered all the formulas or something, but just because I know how to use and how to apply dimension analysis, it really helps me, and it helped me, and it's still helping me even up to now to know formulas. Yeah, so what's just important is knowing what's this? It's just knowing the units. Yeah, it's just knowing the units of the quantities that you've been given in the question. So let's quickly move to the solution. So they are asking us to find the velocity. So we are going to say velocity is equal to k. So this k can be any number, it's a constant, it can be any number. So I'm going to say k, and then they are telling us to say it's affected by the compressibility. So compressibility is E subscript V, and then the density. So the density is rho, and then we also have what? The kinematic viscosity, which is, I'm going to write it like this, so that at least it's different from this other V. And then they're asking us to use dimension analysis to find the expression for V. Okay, so the most important thing, or the first thing that you need to do when you've been asked such a question is you first have to write the dimensions for all the expressions that you've been given. So the dimensions for V, we want to say the dimensions for velocity, we derived that in the previous slide. So dimensions for velocity are simply L, we just said it's L t to the power -1, but we can also add m to the power 0. It's still fine, because any number or any letter raised to the power 0 will still give you what? It will still give you 1. So it doesn't matter whether we add m to the power 0 or not. Okay, so the dimensions for velocity are simply just L. And then apart from L, you also have m to the power 0. And then we also have what? Also have t to the power -1. So these are the dimensions for velocity. If you want, you can leave out m, there's no problem. But I like putting all the three quantities, all the three dimensions. And the one that is missing, I just raise it to the power 0. Yeah, so these are the dimensions for velocity. We also find the dimensions for density. So how do you find the dimensions for density? We know to say density is equal to mass over what? Over volume. So the mass, the dimensions for mass is what? Capital letter M. And then the what's this? Dimensions for volume is simply just, we know to say volume is measured in meters cubed. So this is meters is simply just length. So this will be the length to the power what? 3. So we have length to the power 3. And then this can be written as, so the density there can be written as m to the power 1 and then L to the power 3. But we don't have t here. So since we don't have t, I can also just add t to the power 0 there. So the dimensions for the density is simply just, let me arrange them according to the way I've arranged the velocity. So L, and then we also have m to the power, L to the power 3 there, then m to the power 1, and then t to the power 0, t to the power 0. Then we also have to find the dimension for compressibility. So compressibility, the dimensions. Okay.
So I have a question
Oh, this
on
one, density.
yeah,
Yeah, it's supposed to have a
density.
negative.
Okay, sir. Thank you.
Supposed to have a negative. I just saw it up. The moment you just said, sir, I need to say I've made a mistake somewhere. Okay, so it's supposed to have a -3 there. Okay, so we find the dimensions for compressibility. So this one is simply just, we know that compressibility, which is EV, is measured in what? In meters, or sometimes, let me just start with kg. So it's measured in kg meters. It's measured in kg seconds per watt. Oh, sorry. I'm trying to remember the units for compressibility. So compressibility, the units are simply just the meters, and then you have meters seconds squared per kg. Yeah, these are the units for compressibility. Yeah, so it's meters squared per kg. So what this means is that our dimensions will be L for meters for the length, and then time, this will be t to the power 2, and then we have per kg. Kg is the mass, so we have m down there. So we can have m to the power -1 there. Then we erase the one that is down. Yeah, so these are the dimensions for compressibility. So we have L, then we have t to the power 2, then we have m to the power -1. So we have found the, we also have kinetic viscosity. Yeah, so the dimensions for kinetic viscosity, we know to say kinetic viscosity is measured, its units are just the meters squared per watt per second. So this implies that the dimensions for kinetic viscosity are simply just going to be what? So we're going to have meters there, that's the length. So we have length squared, and the time there, the second, is simply just time. So this is going to be time to the power -1. Okay, so we have V. This is kinetic viscosity, and this is going to be the dimensions we found are, we have L to the power what? 2, and then we have T to the power -1. Then apart from that, we also have M to the power 0. Okay, so I found all the dimensions. We're trying to find the formula for the speed, or the speed of a wave, of a pressure wave traveling through a fluid. So now let us try to let us now find that formula. What is that formula? So we are imagining that we don't know the formula, and we need to find the formula. So now I'm going to write this formula in terms of the dimensions that we've been given there, that we have found. So the formula will then be equal to, so for the velocity there, I'm going to have these there. I'm going to write them. So we have L, then we have M, then we have T to the power -1. And we say this is equal to, we have K there, this K there, and then open brackets, we have the dimensions for what? Compressibility, which are L T2 M -1. So we have L T2 and M -1. Then we also have the dimensions for what? For density. So the dimensions for, so what we're going to do is this. Let me do this. I think, let me just put these brackets like that. I think just for us to have enough space, let me do this. So we have that, and then dimensions for, when this side, I'll do the same, so that we can have enough space. Because if I draw a lot of brackets here, I'll fail to cover everything here on the same board. All right, so for velocity, I'm going to have L, then I'll have M0, and I'll have T -1. And then we have K there, open brackets. Then for compressibility, we have L, we have T2, then we have M -1. And then we also have, I'm going to raise this to the power X, because I don't know the power of compressibility, the power that compressibility is having. So I'll just raise it to the power X. Then for density there, for density, I'll do the same. I'll write the dimensions for density, which is L3, L to the power -3, and then M1 and T0. Then I'll raise this to the power Y. Then the dimensions for kinematic viscosity are simply just L2, T -1, then M0. Then I'll raise this to the power Z. So we have that power Z. Then this is the formula that we have. Now, our duty here is to find the value of X, Y, and Z. That is what we are supposed to do. So when we take the powers of L on the left, the power of L on the left is what? The power of L on the left is 1. Then we say this is equal to the power of L on the right. In the first part there, we have L to the power 1. So this 1 times X there, I'm going to get 1 times X, I'm going to get X. So I'll write X there. And then in the second dimensions there, the power of L is what? Is -3. So -3 times y, I'm going to have -3y there. Then the power of L in the third set of brackets there is 2. So we have 2 there times what? Times z there. So we have plus 2z. So this will be our first equation. We move on to the powers of m. So the power of m on the left there, we have what? We have 0. Then the power of m on the first part there is -1. -1 times x, we get -x. Then the power of m in the second set of brackets is what? +1. 1 times y, we have +y. Then the power of m here is what? Is 0. So 0 times z, that is going to, that will just give us 0. So this is going to be our second equation. And then we move on to the third equation, which we're taking the powers of t. So the powers of t here on the left, we have -1 there. Then this side on the right, we're going to have the power of t there is 2 times x there, we're getting 2x. Then the power of t there is 0. 0 times y, the answer is what? 0. Then the power of t there is -1. -1 times z, we're having negative what? Z. So here, there, what we have here, we simply just have to take this -x side to that side. The reason why I'm doing that, okay, here, what I'm just trying to do here is to solve the simultaneous equations. So we have 3 simultaneous equations here, which we have to solve. Yeah, we have 3 equations that we have to solve simultaneously. So how do we do the solving there? So we can make one of these equations as a substitute value. What does that mean? It means that we're going to make one of these variables as the subject. So I'm going to take this one here. So I'm going to have -x plus y is equal to what? 0. So I'll take this to the other side of the equal sign, and I'm going to have x is equal to what? Y. So now when I do that, where there is x in this first equation, I'm going to replace by, so while there is x in the first equation, I'm going to, okay, let me just say, while there is y, while there is y there, while there is y here, I'm going to replace with what? With x. Yeah, so in the first equation, while there's y, I'm going to put x. So I'm going to have, because I've seen that x here is equal to y. So while there's x, I can put y, and while there's y, I can put x. So I'm going to have 3. Then while there's y there, I'm putting x, and we say plus 2z. So when we add this, we're going to have -2x plus 2z. And then we solve it simultaneously with the third equation there. So we can make z the subject of the formula in this equation, and z is simply just going to be equal to 1 plus what? 2x. Yeah, so while there is z in this equation, I'll put 1 plus 2x. So I'm going to have 1 is equal to -2x plus 2, 1 plus 2x. Then after finding that, I have to simplify that. So I have 1 is equal to -2x, then plus 2 plus 2 times 2x, that will give me 4x. So this 2 can go that other side, so that I have -2 this side, 1 minus 2 this side, and this other side I'll have -2x plus 4x. That will give me what? 2x. And yeah, that will give us 2x. And then this side we have -1 is equal to what? 2x, meaning the value of x becomes what? -1/2. So if the value of x is -1/2, means that the value of y is also -1/2, because we know to say x is equal to y according to these equations that we have found here. We know to say x is equal to y. So since x is -1/2, it means that y is also what? -1/2. Then we find the value of z. So the value of z will be taken from here. So we know that z is equal to what? 1 plus 2x. So while there is x there, I'm going to replace with the value of x, which is -1/2. So the value of z is simply just going to be 1. This and that will cancel, meaning we just remain with what? -1. So this is going to be 1 minus 1, which is 0. So the value of z is equal to 0. So now having written, okay, so in writing this formula, I was supposed to put x, y, and z there, so that this part makes sense, where I had put all their dimensions raised to the power these same variables x, y, and z. Okay, so we can now write our formula. So our formula for the velocity is now going to be equal to k. Then the power of compressibility there is x, and x has been found to be -1/2. So we say EV to the power -1/2, and then the density is also raised to the power y, which is -1/2, and then the kinematic viscosity is raised to the power 0, which is just the same as 1. So now the final answer will therefore be equal to, let me write the final answer here. So the final answer, which is the formula they were asking us to find, will then be equal to, okay. So the final answer will be V is equal to, we know there's k there, and then anything raised to the power half is just the same as the square root of that thing. So we have something like this, then to the power -1, and then rho is also the square root of rho, the power at -1, and then v to the power 0 is simply just 1. So when you simplify this further, you get k. Anything raised to the power negative is just the same as over that. Then multiplying that with the root of the density. So the final expression for velocity will therefore be equal to, so the V is then going to be equal to k over the square root of what? Compressibility times the density. So that is the formula for the speed of a pressure wave traveling through a fluid. All right, so when this link ends, you should join so that we proceed with the next question. We finish up the next part. So it's about to end. When it just ends, you should rejoin again. So